There's an interesting connection between graph theory and commutative algebra. Binomial edge ideals turn any graph into a set of polynomials. These polynomials generate an ideal which provides valuable information about the structure of the graph. Let's begin with a more intuitive construction, edge ideals. Consider this graph with 4 vertices. For each vertex, we will adjoin a variable to our favorite field k. Remember that graphs are defined by their edges, and here we will say that an edge between a vertex I and a vertex j will be denoted by the monomial xi, xj. The set of edges, denoted in this way, forms a generating set for our edge ideal ig. This ideal holds a lot of information about the graph. For example, its prime decomposition corresponds to the minimal vertex covers of the graph. Here is a formal definition of edge ideals in terms of the edge set of G.
Suppose that instead of constructing a monomial for every edge in a given graph, we construct a binomial. The ideal generated by this collection of binomials is called the binomial edge ideal, Jg. This construction is more complicated, since for a graph with n vertices, we have to adjoin the variables y1 through yn to our field k, in addition to x1 through xn. Let's look at this graph as an example. This happens to be a closed graph, meaning that the generators displayed below it form a Grosvenor basis with respect to the lexicographic order induced by this variable order. Keep in mind that there are many different definitions of closed graphs, but we won't discuss all of them here. The binomial edge ideal leads to a construction called the generic initial ideal, the minimal generators of which correspond to paths in the graph. In this case, we see that there is a path between vertices 1 and 2, 2 and 3, and 1, 2, and 3. We'll finish off the video with some more nifty facts. The complete graphs give examples of determinantal ideals, which are very well studied, and the primary decomposition corresponds to different ways to split the graph into pieces by removing vertices. If you're interested in learning more about binomial edge ideals, make sure to check out the other videos posted to this channel.